More than 100 million Americans suffer from chronic pain. But why do we feel pain? What is happening physiologically that we've resorted to overusing pharmaceutical drugs to treat our symptoms? On an average day in the United States, more than 650,000 opioid prescriptions are dispensed to treat chronic pain, and 78 people die from an opioid-related overdose. Is there a solution that is natural, less addictive, and also treats the underlying problem? Act 1. The role of stem cells in the healing process. Adult stem cells, also known as mesenchymal stem cells or MSCs, are also known by the name pericytes because they wrap around the outside of blood vessels. Peri means around, like in the word perimeter, and cyte denotes a cell. When a trauma occurs, the MSC pericytes are released from nearby blood vessels and migrate to the site of injury. The MSCs help clear the wound of any infection by modulating local immune response, recruiting scavenger cells called macrophages to destroy pathogens, and release antimicrobial bioactive agents to assist with bacteria removal. As a response to the injury, inflammation soon takes hold, and the MSCs control it by regulating various proteins and growth factors, similar to a conductor in a symphony. It's during this phase where the body feels pain. By regulating the inflammation process, MSCs ensure the body recruits necessary cells to cease wound inflammation as soon as possible. After the inflammation subsides, the MSCs secrete growth factors to encourage blood vessel formation and recruit and nourish specialized cells that rebuild structural tissues. During this phase, known as proliferation, the MSCs adjust the concentration of released proteins to stimulate collagen production for tissue formation and wound closure. In the following weeks and months, local cells remodel the fibrous proteins like fibrin and collagen based on the biomechanics of the tissue to create a mature tissue. The MSCs continue regulating the healing process until the remodeling phase is complete, and then return to vascular bed resting until they are signaled back into action. Act 2. The breakdown. As the body ages after skeletal maturity, its vascular supply of capillaries decreases in many tissues, especially in cartilage of joints and discs in the spine. Without local blood vessels, there are fewer local MSCs to respond to an injury. When injuries occur in these low blood supply tissues, there are no MSCs to oversee the healing process by modulating the inflammation or recruiting cells in for repair. The result is disrupted communication between the local cells and its other healing mechanisms, like a symphony that's lost its conductor. Some wounds may even enter a chronic inflammatory state, where the body is never able to efficiently rebuild new tissues. Chronic inflammation can result in long-term pain and loss of function. Often, osteoarthritis and degenerative disc disease can arise from these chronically inflamed injuries. Another clinical pathology associated with a decreased blood supply is non-healing wounds and ulcers. Blood vessels provide essential nutrient and waste molecules as well as MSCs to modulate inflammation and signal epithelial and endothelial cells to close the wound. Additionally, MSCs have been discovered to release antimicrobial bioactive agents to fight infectious material. Even if these injuries transition beyond the inflammation stage, the lack of MSCs can affect how new tissues form and connect. Without sufficient MSC counts, the new tissues may be heavily fibrous and scarred and may not be appropriately remodeled to withstand everyday wear and tear. As a result, chronic pain and/or injuries fail to heal.